Hi, in this video I'm going to be going through the Single Award Science Chemistry paper, and this time I'm doing the higher tier questions. I've already done the foundation tier, so if you're sitting foundation tier you might want to have a look at that paper instead, or as well as this one. So the time for this paper is 1 hour and it's 60 marks, and this was the specimen paper provided by CCEA when they changed the specification. So, question 1. The table below gives information about different materials. And here are the materials: polythene, carbon reinforced plastic, nylon and Kevlar. And then we have their relative strength, relative heaviness, relative cost and relative flexibility across the top. So then it says, explain why a company would choose polythene to make plastic bags. So you think about what a plastic bag is used for. It needs to carry your groceries or whatever you're bringing back from a shop. So we're looking for its, usefulness or its properties up here. So strength is 2, which is not very good compared to the others. Its heaviness is 960, so it's the lightest of the lot of them. It has low cost and it is really very flexible, most flexible of the lot of them. So you could have mentioned that those 3 properties: it's flexible, it's light and it's cheap. Any 2 of those would have got you 1 mark. And then explain the property. So it's light, so it won't add to the load. Next one, a company has a contract to make climbing ropes. Suggest the material they should use and explain your answer. So a climbing rope, you want it to be strong. And if we look at strength here, so carbon reinforced plastic is quite high. Kevlar is really high. Nylon's okay. But we also want it to be flexible so you can actually, tie it round things. And out of those 3, then the carbon reinforced plastic and the Kevlar are fairly terrible with flexibility. But the nylon is pretty good. So you would pick nylon because it's flexible and it's strong. And there are 3 marks for that. 1 for nylon, 1 for flexible, 1 for strong. So the student carried out 3 tests on 3 gases. The results are shown below. So we have X, Y and Z, all colourless gases. First one turns lime water milky. Second one burns brighter with a lighted splint. And the third one burns with a squeaky pop. So which one would be hydrogen? So Z, 1 mark for that, and then your reason, your piece of evidence, because it burns with a squeaky pop. So always remember, if it's like which one and give a piece of evidence, there's 1 mark for each of those parts, so there's 2 marks in total. Then he suspects that Y is oxygen. Describe the test that would be used to confirm that it's oxygen. So the test is you would use a glowing splint, and the thing that confirms that it's oxygen is it relights, so 2 marks there. Question 3. Ethane, C2H6, is a hydrocarbon. The family of hydrocarbons that this belongs to is the alkanes. Anything that ends in ane is an alkane. Then in the space below, draw the structure of ethane. So they've given you the formula, C2 and then 6 hydrogens around those. And make sure that you always have 4 bonds around each carbon. Okay? Then describe the combustion of ethane. You should include the definition of a hydrocarbon, the names of the products formed, and the impact of combustion on the environment. So a hydrocarbon contains only carbon and hydrogen. That's your definition. So that would be sort of 1 tick if we're thinking of it in those terms. Then the products, you have 2. You have carbon dioxide, so that would be 1, and water, which is another 1. So that's 3 marks just for those simple points. And then the final bit here, so you're going to get your other 3 marks out of the 6 for this. So is linking the fact that carbon dioxide is a greenhouse gas, okay, and is going to lead to global warming. And then any consequence of the global warming, so like climate change, ice caps melting, any of those sorts of ideas. So you'll notice these little sort of marks that I've made for each one. If you're getting between 5 and 6 of those and using good English, because it's one of these SPAG questions, you're going to get 6 marks. Between 3 and 4 with good English is 4 marks, and 1 to 2 of those points with good English would be 2 marks. Next we've got this graph. So the graph shows the percentage of carbon dioxide in the atmosphere since 1700. So use the information to complete the table. So what I've done is just drawn lines here across to show to work it out for myself. So at 1800 it's 0.028, then 0.029, 0.03 and 0.032. So describe fully the trend in the graphs. The level of carbon dioxide remains constant until 1800, and then the level rises. And then predict the percentage that'll be in the atmosphere in 2050. So 0.04 or above. So you're just looking at this graph here and sort of extrapolating up. So it's going to be above this number here. Okay, number 5. A student used chromatography to find the different coloured dyes in a black food colouring. A sample of the colouring was placed on filter paper and then it was dipped in water. The results are shown below. So what colour is the least soluble in water? So least soluble has travelled the least distance from the baseline. So that's yellow. What is the student used as a mobile phase in the experiment? Well, it tells you up here it was dipped in water. So water is your mobile phase. And then the RF, calculate the RF value for the blue dye. So you're looking at how far has the blue dye travelled, and that's up to 8. And the solvent front then is 9, so it's 8 divided by 9, which is 0.89. Number 6, magnesium reacts with oxygen to form the compound magnesium oxide. So in the space below, complete the diagrams to show the arrangement of all the electrons in a magnesium atom and an oxygen atom. And it says you may find your data leaflet helpful, so you look up magnesium and oxygen, look at their atomic numbers. That of course tells you the protons and then the number of electrons. So magnesium has 12, so 2 in the first shell, 8 in the second shell, and then 2 in that outer shell. And oxygen is number 8, so 2 in the inner shell, and then 6 around the outside. And if you group them like I have, it's much easier for the examiner to actually count them. So 1 mark for each of those. Explain how the electron arrangements of a magnesium atom or magnesium and oxygen atom change when magnesium oxide is formed. So you're making sort of a point here about each of them, what's happening with their electrons, and then what their electron arrangement actually is at the end. So magnesium is losing 2 to have the arrangement 2, 8, and then oxygen is gaining 2 electrons and it will also have the electronic arrangement 2, 8. So 3 marks in total there. And the formula of each ion, so magnesium is losing 2, so it's Mg2+, and the oxygen is losing 2, or is gaining 2 to become an oxide ion with O2- as its formula. Number 7, aluminium is extracted from aluminium oxide using electrolysis. The apparatus is shown below. So you see here the anode dipping down into the tank filled with aluminium oxide and molten cryolite. We've got the cathode lining the tank, and then we have the steel tank around the outside. So it says the aluminium is formed at the cathode. What's the meaning of the term electrolysis? So 2 marks for this. It's breaking down a compound using electricity. And what's the meaning of the term cathode? So the cathode is an electrode, and remember, don't panic, positive anode, negative cathode. So it's the negative electrode. And then describe in terms of ions how the aluminium is formed at the cathode. So aluminium ions are going to have a charge of +3. They're going to gain 3 electrons to become aluminium atoms. So that's 1 mark there for the ions gaining, and then 3 electrons is your second mark. Then the half equation for the reaction at the cathode. So this should be one that you have learnt straight out of your notes. So there's 1 mark for the products and 1 for the reactants. So Al3 plus 3 electrons, you write that as 3E minus, gives you Al, so 2 marks. And name a suitable material for the anode and explain why it's used. So graphite, you could say carbon, but it's better to say graphite, and because either it's inert or it's a good conductor. Then explain why the anode needs to be periodically replaced. Well, because the anode is made of graphite, which is carbon, it's going to react with the oxygen that's produced, and then it wears away. So 1 mark for saying the oxygen that's produced reacts with it as your second mark. Okay, one reason why recycling aluminium is better than constantly producing new aluminium, well, because it saves resources. You could go into, uses less energy and so on, but ultimately that is saving resources. Now we've got sort of question that you might look at initially and think, oh, I'm not quite sure, but this is just, when you read on, it's really just about percentages. So below is the ingredients label found on a popular indigestion tablet. It doesn't really matter what it is, it's just giving you all these different chemicals, and it tells you what it contains. So it says use the information and your knowledge to answer the questions below. So calcium carbonate and calcium hydrogen carbonate are described as the active ingredients. Calculate the percentage of active ingredients in each tablet and show your working out. So to find a percentage, you need to know what the amount of the stuff that you're looking for is. So the calcium carbonate here is 700 and the calcium hydrogen carbonate is 50. So 700 plus 50 is 750. And you also need to know the total so that you can work out what percentage it is of the total. So the total mass, I've just added everything in this table: the calcium carbonate, calcium hydrogen carbonate, sucrose, glucose, peppermint flavour, talc, all those things. You add the numbers up, you get 1,500. So 750 divided by 1,500 and multiply by 100 will give you your percentage, which is 50%. Part B, the chemical formula of calcium carbonate is CaCO3. So how many atoms are represented by the formula? So atoms, we've got one calcium here, one carbon, and then 3 oxygens. That's a total of 5. Then it says the chemical formula of calcium hydrogen carbonate is CaHCO3, and that's in brackets with a 2 beside it. So I read that as CaHCO3 twice. So that means there's 2 lots of this here, the HCO3. So how many oxygen atoms and hydrogen atoms are present in this formula? So oxygen, we've got 3 in here multiplied by the 2, so that gives us 6. And then hydrogen, I've got 1 inside the brackets multiplied by 2 gives me 2. Name the element that's present in calcium hydrogen carbonate but not in calcium carbonate. Well, it's in the name, it's hydrogen. Part C, calcium carbonate is found in the form of marble chips, can react with hydrochloric acid to produce carbon dioxide gas. Complete the balanced symbol equation to represent this reaction. So calcium carbonate and hydrochloric acid are going to give you calcium chloride, which is CaCl2, and then any carbonate reacts to give carbon dioxide gas, which is CO2, and also water, which is H2O. Now, it just so happens that that is balanced. You don't need to add any numbers. So there was 1 mark awarded for the formula of calcium chloride and 1 for the correct formula for water and carbon dioxide. Next, the student measured the rate of reaction between marble chips and hydrochloric acid by measuring the amount of carbon dioxide gas that was made every 30 seconds. The experiment was then repeated using more concentrated acid. So describe one difference the student would observe when the concentration of the acid was increased. So if it was increased, the reaction would finish sooner, or it would bubble more quickly, or the gas would be made faster. So any of those would be acceptable. Then describe in terms of particles what happens in this reaction when the concentration of the acid is increased. So first thing you need to say is that in the more concentrated solution there are more particles. Your second mark is that more particles mean more successful collisions. Don't just say more collisions, because it only helps the reaction speed up if those collisions are successful. And then finally, more successful collisions means a faster rate of reaction. And those are your 3 marks. And finally, describe a test the student could do to confirm the gas was carbon dioxide. So that would be use lime water, and if carbon dioxide is present, it turns from colourless to cloudy, or you could say milky. And the very last bit, the student found that during this reaction the temperature had increased. So what name is given to this type of reaction? So that is exothermic, because energy has been given out. So that is all of the higher tier chemistry single award paper. I've also done the foundation one, which you might like to have a look at. Thanks for watching.